Okay, so in this video we're going to look at some more rather complicated situations which are not easy to necessarily even solve using partial fractions, but other methods work. For instance, if you see this rational function here, now this is an improper rational because these two powers are the same. So now one would proceed to do long division here, and after doing long division we end up with, so basically long division tells us that this is equal to 1 plus x minus 1 over 4x squared minus 4x plus 3. The problem lies here in this denominator. In this denominator. The denominator is an irreducible quadratic. Now if you can't factor it out, how are you going to be able to do any partial fractions? So that is not the end of the world. Now you need to understand that partial fractions are not the only way to solve rational functions. We can complete the square in this particular case. So that would mean that this is going to be, so the denominator can be written as this, 2x minus 1 squared plus 2. Now once we have that, clearly our integral becomes, so basically our integral is going to be then in that case, so the integral becomes the integral of course, the 1 plus x minus 1 is still there in the numerator, and then in the denominator you've got 2x minus 1 squared plus 2, and of course we've got the dx. So now the 1, of course, you can see is quite easy to do. Let's isolate this particular integral here, this one. So then what happens is we're going to do this integral. In order to do this integral, we're going to say let u equal 2x minus 1, which means that du is equal to 2 dx. You've got that, which means that now remember, from this we know that x is going to be of course a half into u plus 1. Okay, I hope you can see that. Now when we go back to the integral, so x minus 1 is going to become half u plus half minus 1. That's on the top, and then you've got the du and a half over here. Okay, and then you've got 2x minus 1 is u squared, so this is just going to be u squared plus 2. Now that's going to then further reduce to just 1/4 the integral of u minus 1 over u squared plus 2. Now we can further split that integral into, leave the quarter outside, okay, and you've got the integral of u over u squared plus 2 minus 1 over u squared plus 2. Of course, I forgot the du here, sorry about that. And so there's du and there's du. Now we proceed further, and this one, then leave the quarter outside. The first one is easy. The derivative of u squared plus 2 is 2u, so another half adjustment comes in, and it's going to be the log of u squared plus 2. And then you're going to have minus, and if you remember, that's the same as the tan inverse we did before, except this time you've got 1 over root 2. So a is square root 2, so you get 1 over square root 2 tan inverse of x over root 2. Okay, so here what will happen is, of course, 1 over 4, remember this will be, I forgot, yeah, so this, don't forget the 1 over 4 over here. So now as we change back, we're going to get 1 over 8 ln of 4x squared minus 4x plus 3, and then we'll have minus 1 over 4 square root 2, and tan inverse of u, remember, is 2x minus 1, so it will be 2x minus 1 over square root 2. And now let's combine. Remember, this is the integral we actually solved, this one here, this integral. So as we proceed now to finish it, we'll have the first part will be just x, so this is equal to x, and then we'll have plus, so we'll have plus all of this, and then finally we'll end up having here our constant c. So there's this integral basically sorted out. And as you can see, we didn't really use partial fractions in this rational function. Another quick example I want to show you is this one, where you might be required to integrate, for instance, something quite straightforward, like this, x squared minus a squared. Now remember, when that happens, usually what we've been doing is using a trigonometric substitution here. So we could use x equals a sec theta, and that'll do the job. But there's a now we know another way of doing this, and that is you can split this into x plus a into x minus a. Okay, and then proceed. For instance, here, if I proceed on the side to do this, so we're talking about 1 over x plus a into x minus a, then the partial fractions would be a over x plus a plus b over x minus a. And then, of course, we proceed, and that's going to be equal to a into x minus a plus b into x plus a. And then, of course, we let x equal a, which means we end up with b. b is going to be a plus a 2a, so it's 1 over 2a. 1 over 2a. And similarly, we let x equal minus a, and that will give us that a is equal to minus 1 over 2a, which means this integral will become the integral of excuse me, minus 1 over 2a x plus a, okay, and plus 1 over 2a x minus a. All right, dx, of course. And of course dx. So this, as you can see, can easily be solved then. Minus 1 over 2a ln x plus a plus 1 over 2a ln x minus a. Okay, and that's plus a constant. Now, of course, you can combine these because we can write this as 1 over 2a is common, and you'll have ln of x minus a over x plus a plus a constant. So as you can see, just a quick alternate way now that you have, so you don't have to use this trigonometric substitution. The same answer you'll arrive at the same answer in the end, but now you have an alternative method of doing this. So just wanted to look at some different types of example where things are not exactly as you seem. In this first example here, we saw that whereas division does help, we can't really split it into partial fractions, which doesn't mean it's the end of the world. We can actually proceed to do it using some completing of square, and then some very simple algebra leads to, and a good substitution leads to the integral sorted out. Here in this second example, I just wanted to demonstrate that this is something we did using a trigonometric substitution. Now, in this particular case, because there's no square root, we can proceed to basically work this out as a partial fraction. Remember, if this was the integral of dx over square root of x squared minus a squared, then this is the only way that will work. Okay, you cannot split this into partial fractions. Anyway, hopefully you have some idea about integration and partial fractions, and we'll stop here. Thank you very much.